Okay, this is F.IF.7.a, interpreting functions, standard 7, subpart A, video 4. We are graphing using slope-intercept form today. Um, we're going to stick with the linear function idea. We're not going to be doing quadratic functions, and we're not going to be talking about maxima and minima. Just a reminder, that's what we're going to be talking about near the end of the year when we're graphing quadratics. Couple terms to know: slope-intercept form and parallel. Please get those in your journals. Okay, slope-intercept form. Up to this point, we have talked about standard form. We've taken function tables, had some input values and some output values, and we were able to graph the ordered pairs to create these linear equations, these lines on a grid. We also talked about finding intercepts and graphing lines using two intercepts, the x-intercept and the y-intercept. And today we're going to use something called the slope-intercept form, and this is a form that you're going to be using a lot. And it kind of relates back to literal equations when we were isolating one variable in particular. And in this case, we're going to be isolating the y variable. We're going to get everything over to the other side. Okay, let's take the first one and practice moving every term over to the right other than a positive 1y. All right, here's your wall, and let's isolate that y. And what am I going to do to get the 4x to the other side? I taught you to carry the entire term over and then change its sign once you get to the other side. So I have 1 minus 4x. And I did that on purpose. You know, according to the formula or the form that we have above, they want the mx to be first and your constant b to be second. Okay, so let's rearrange that. I have y equaling, I take my negative 4x and put it first, and then I have my positive 1 that I kept there on the right side, so it remains positive 1. Okay, so let's label these. My m, my slope m, and we've talked a lot about the slope, is negative 4. And my b, which is my y-intercept, I'm going to talk about what that is in a second. And that should be at positive 1. Okay, again, let's rearrange the second equation, and then we're going to go talk about what these variables do. Well, we know that the variables x and y create ordered pairs, but we're going to talk about what the letters m and b do for us also. Okay, so here's our wall. And let's isolate the negative 3y. And instead of going negative 9 minus 6x, let's just do that right away. So I take the 6x, it was positive, it becomes negative on the other side. There's my mx going first, and then my constant, since I have one, which is negative 9, will remain negative 9. And now the inverse operation of multiplying by the coefficient negative 3 is dividing everything by negative 3, all terms. Okay, how's that going to simplify? We're going to end up with y equaling negative 6 divided by negative 3 is positive 2, and then negative 9 divided by negative 3 is a positive 3. So if I were to label these, I have an m equaling 2 and a y-intercept equaling positive 3. Now those are going to be important when we go and graph lines. Okay, speaking of lines on a coordinate plane, I have one here, and it says find the slope of the line. I can actually do more than that. I can not only find the slope of the line, which is your m, but I can also find the y-intercept, and B is known as the point at which your line crosses the y-axis. So let's write that down here. So B is equal to your y-intercept. And we talked about y-intercepts before. We know what that means. It's where your line crosses the y-axis right here. Okay, so let's just fill that in right away. I follow my purple line. I have an x-intercept, which right now I'm not worried about. The B is my y-intercept, where it crosses my y-axis right here, and it looks like my B is going to be at -1. So let's fill that in right now. So B is -1. I have a y. That's the y coordinate of my ordered pairs. Here is my x. That's the x coordinate of my ordered pair. And now I need to find m. And m is the slope of the line. So how steep is this particular line? And we talked about it earlier being the fraction of the rise over the run. Okay, so we pick out a couple of points. Let me get my cursor out here. And if we pick a couple of points, any point on this line right here should be a solution to my equation. So I'm going to find a couple of points in which my line crosses the two grid lines at the same time. I call it a little hit point. So where does it hit all of the lines together? I see one right here. I could graph that ordered pair, and then I find a couple on this line. I see that it crosses two grid lines at the same time here, and we know that our intercept is also going to be one of these ordered pairs that are solutions. So let me just put dots. Let me get a large dot on those for you. That's pretty big. Okay, so if I put a point here and a point here, another one, there might be one up here somewhere, and if I am finding the slope of the line, I could run the points, the ordered pairs, in my slope formula, which we learned on the last video. But quickly, let's just do a little triangle. Looks like I could form a 90-degree triangle here by doing my rise. So let's go. Rise is 1 unit, 2 units. So that would be my numerator. So if I rise 2, that means +2 over my run would be to the left 1 unit, and I'm on my point. And left means -1 unit. So if I were to simplify that fraction, +2 over -1 is a -2 slope. So there is your equation of the line. Y is equal to -2x minus 1, because I have my B, or my y-intercept, down here at -1. Okay. Now it's your turn. We need to graph the equation. After we make sure it's in slope-intercept form, following the y equaling mx plus b. And again, I chose this one because I thought it might be a little confusing to you, because you see that we have y equaling m is my fraction rise over run x, so y equals mx. I have a missing b, so think to yourself, what might be that missing b? Okay, you're right, it's a 0. So if you want to put it in, you can. It could be +0, -0, and that is your starting point. Okay, so if that is my y-intercept, my line in some way or fashion is going to cross, let's get a different color, it's going to cross at the origin, 0. And from that point, I am going to use my slope to generate all of my other ordered pairs. So we have m equaling the rise over run of 2/3, or another way of writing 2/3 is -2 over -3, because that's also a positive 2/3. And you could go on and on. If you want to have another fraction, an equivalent fraction, I could say what? Maybe, how about 4/6? And if you reduce that, you'd get positive 2/3. Again, you can go on, and all of those fractions would be getting you points on your line. And let's go find all those other points. So we start at the origin, and according to the first fraction, it says rise 2, run 3. So follow my cursor, rise 2, run to the right, because it's positive, 3. From my new point, I could go again with the slope of rise 2, run 3. Now I'm running out of room in my upper right quadrant. So how am I going to get the bottom portion of my line? Well, I'm going to use my other fraction that I created. And that would be this one right here. So from my origin, I'm going to go down 2, because it's -2, and left 3, because it's -3. Down 2, left 3. Then you take out your straight edge, and you have your line. And let's see, we're going to go all the way down through your grid. And it looks pretty good to me. And if you want to label it, feel free to label it y equals 2/3 x. So again, here's your b, and then you use the given slope, which is your m, 2/3. All right, here's another straight line. It looks to be horizontal. Horizontal line, if you recall, means that we don't have a slope. So if I were to put it into form, y equals mx plus b, we see that my m is 0. So what's going to happen mathematically, if I have a 0 slope, anything you multiply by 0 disappears because it becomes 0. So y is equal to nothing plus or minus b. And I say plus or minus b because adding is the opposite of subtracting. So your b can be positive or negative. All right, now let's see what that is. So if y is equal to b, my b is my y-intercept. So y is equal to my intercept, which is at -2. So the equation of the line in slope-intercept form is y is equal to -2. Even though we are missing the mx term, we know that it kind of disintegrated when we found that our slope was 0. Okay, last one. This one's a little bit more difficult. It says find the value of k so that the lines through the given points are parallel. Now what we know about parallel lines are that they will never intersect. And what do you need to know about lines that don't intersect? What is common between them? You're correct. Your slopes must be identical. Let's say that the slope is 1/2. Or maybe I could go back to this picture right here. Clear that off for you. Okay, so if I have a given line, I'm just going to make one up here. If I have a given line like so, I'm just going to throw some dots. Okay, so here's my line, my red line. In order for these lines, the red line and now my blue line, to be parallel to each other, notice they're never going to intersect each other, I must have the same slope. So let's check out the slope of the red line. It looks like we're going to go up 1 and right 1. So my slope is going to be 1. And then with my blue line, we are going to go, I'll take any points, how about down here? I'm going to also go up 1 and right 1. And that means that is also a 1 slope, positive 1 slope. So the general rule, the specific rule actually, is that if lines are parallel, they have the exact same slope. Not necessarily the same y-intercept, right? Because this y-intercept is 1, and this intercept happens to be something else, and that's okay. All right, so where do we begin here? Well, if I need to find this missing value of k so that line 1 is parallel to line 2, I need to find the slope of both lines. Well, since I'm given all 4 coordinates, or the 2 coordinates here with all 4 x and y coordinates, I'm going to find the rise over run of the line 1. So line 1 should be, and we use our slope formula, or you can draw it on a piece of graph paper if you want. So let's go, what's the easiest here? How about, let's take -2 subtracted by 0, and then -4 subtracted by 0 also. And we have -2 over -4, which if we simplify that, you'd get positive 1/2. So m for line 1 is 1/2. And that means line 2 must also have a reduced fraction of 1/2. Let's go figure out what that is. Okay, so I have my rise over run and my difference between the two. And I personally like to have my variable first when I'm setting up these ratios. And if k is going to go first, that means I'm going to start with this ordered pair being my sub 2's. Oh, sorry, that should be an x sub 2, y sub 2, because I want to begin with those. So let's go. Y sub 2 minus y sub 1, which is 7, is going to be over the denominator, or the run of k minus 2. And let's simplify. So 5 minus 7 is -2 over. Now think about what I need here in order for this fraction, my line 2 fraction, to be 1/2. Well, if this is a -2, I know that it's going to have to be a negative number, and that would have to be a 4. So what is going to get me to get a -4 if I set up this equation? So let me just plug in my -4. You could probably think about it in your head right now. What minus 2 equals -4? If not, let's set up an equation. K minus 2 is equal to -4. That's my denominator. It just runs right across here. K minus 2 equals -4. All right, so add 2 to both sides, and that would get us -2. So if I were to polish off this problem, it says find the value of k. I know that k right here would be replaced by a -2. So let's see how that would look down here on the bottom. So I have 2, 7, and the k is replaced by a -2, and then I have my 5. Okay, right here. K is -2. Okay, in your journal, please define the given terms on page 2 of the flip chart, and If you have any questions, write them down, write some things that maybe are new to you in a few sentences, bring those back to class and we'll talk about those.